Hello everyone, I'm Shivpangi Anand, your science teacher, and welcome back to my channel. I hope all of you are blessed in your life. Our today's topic is hybridization and its types. Now students, what is hybridization? Hybridization is the mixture of orbitals. Just like the mixture of salt and sugar, or you can say salt and water, hybridization is a mixture of the orbitals. So students, hybridization word has come from the word hybrid, which means mixture. So what are the types of hybridization? These are the types of hybridization sp3. In sp3 hybridization, one s orbital and three p orbitals, they mix together, combine together to form four new hybrid orbitals which are known as sp3 hybrid orbitals. Now students, here one thing has to be noted. We know that the energy of s orbital is slightly less than p orbitals, but when they combine together, when they mix together, they mix in such a way that the new hybrid orbitals that are formed out of the mixture of this, all four have same length, same strength and same energy. Now, hybridization tells us about the geometry of the compound, because the new hybrid orbitals that are formed, they are aligned in a particular direction. They are directional orbitals. Now in sp3 hybridization, the four new sp3 hybrid orbitals that are formed, they are aligned at 109.5 degree angle, and they form the tetrahedron structure, or you can say tetrahedron geometry. So initially the orbitals are s orbital, p orbital, but after the combination, all the four orbitals have same energy. They are degenerate orbitals. Degenerate orbital mean that they have same energy. Here they are non-degenerate orbitals, but here these, after hybridization, they become degenerate orbitals and their name changes to sp3 hybrid orbitals. Students, you have to note one thing, that the number of new orbitals that are formed, the number of new orbitals that are formed is equal to the sum of the orbitals that are combining. In sp3 orbital, in sp3 hybridization, there is 1s and 3p orbitals. Total of four orbitals are there. So the new orbitals that are formed, they are also in number, they are 4. Moving on to sp2 hybridization. In sp2 hybridization, one s orbital and two p orbital, they combine and they form three sp2 hybridized orbitals, and their inclination, angle of inclination of all the three new orbital is 120 degree, leading to this structure. Now students, we know that there is one pz orbital which is unhybridized. That unhybridized p orbital is depicted from dotted line, and the solid lines show the hybrid orbital, sp2 hybrid orbitals. Now since they are at 120 degrees Celsius, so they are planar. The molecule that is formed out of sp2 hybridization is planar. This is, the dotted line shows the unhybridized pz orbital. Now here also the number of new orbitals that are formed is equal to the sum of the original orbitals that are combining. Since 3 orbitals are combining, so hybrid orbitals that are formed, they are also 3 in number. Moving on to sp hybridization. In sp hybridization, one s orbital and one pz orbital combines to form two sp hybrid orbitals, and these two orbitals are aligned in such a way that they form a straight line, or you can say 180 degree is the angle of inclination of these two new orbitals. Now here also again, look at the diagram shown on the whiteboard. These two are the hybrid orbitals at 180 degree angle, and these dotted line, they show the py and px unhybridized orbital. Clear students? Now students, moving on to our fourth type of hybridization, and that is sp3g. Now sp3d hybridization has two geometries. If dz orbital combines, then hybridization will be trigonal bipyramidal, but if dx square y square combines, then hybridization will be square pyramidal. One by one, square pyramidal. One by one, I will explain you both the hybridization. Now, if dz orbital combines, this is the geometry of the compound that is formed, and the geometry is named as TBP, trigonal bipyramidal. Again, students, here, since 5 orbitals have combined, so the resulting number of the hybrid orbitals is 5. 1, 2, 3, 4, 5. And this structure, or this geometry to be precise, is known as trigonal bipyramidal. Because two times pyramid is formed, one is above this triangle, and one pyramid is formed below this triangle. Here you can see this structure. 3 bonds are in plane. These bonds are in one plane, and one bond is above the plane and one bond is below the plane, and two pyramids are getting formed. One is above the plane and one is below the plane. This is the angle of inclination. 3 bonds are at 120-degree angle, and they are known as equatorial bonds, and 2 bonds are at 90-degree angle to these 3 bonds, and they are known as axial bonds. Now students, here you have to note one thing, that the axial bond are slightly large in length as compared to the equatorial bond, because of the repulsion of the bonds at 90-degree is more as comparison to the repulsion of the bonds at 120-degree Celsius, 120-degree angle. So to overcome the repulsion, the length of the equatorial bond is slightly larger. Now, I will tell you that what will be the geometry of the molecule if instead of dz orbital, dx square y square orbital combines. For that, I have to erase this geometry structure. Yes, students. Now, if instead of dz orbital, dx square y square combines, then the resulting geometry will be square pyramidal. Square pyramidal. Now, students, we know that the square pyramidal structure is like this. This is representing a plane. Now, how does a square is formed? Like this. These are the 4 bonds of the square, and all these bonds are at 90-degree towards each other, because we know that the angle of inclination in the square diagonals is 90-degree, and one bond will be above the plane. That's how the 5 bonds are accommodated, or 5 orbitals are aligned. Now they can form a pyramid of themselves. So that is why the structure is named as square pyramidal, because pyramid is formed but the base of the pyramid is a square. So this is a square pyramidal structure. So because we know that dx square y square is orbital is of this shape. This is dx square y square, but dz square is of this shape. So since hybridization is all about the orbitals and their shape, so changing the d orbital from dz square to dx square y square, the geometry of the hybridization gets changed. Moving on to our 5th type of hybridization, which is sp3d2 hybridization. 5th type is sp3d2 hybridization. Now in this hybridization, one s orbital, 3 p orbital and 2 d orbitals combine together to form 6 degenerate hybrid orbitals known as sp3d2 hybrid orbitals. Now in this hybridization, the resulting orbitals, they are aligned at the octahedron geometry. So the compound that is formed by the sp3d2 hybridization has the geometry of an octahedron. Now students, now in this section of the video, I will tell you that little bit about the origin of hybridization, that why hybridization was discovered. Now students, I'm going to take the example of methane molecule. Now, before hybridization, according to valence bond theory, it was considered that only the valence orbitals participate in the bond formation. Now, when we write the configuration of hydrogen, hydrogen's atomic number is 1, so its configuration is 1s1. But the configuration of carbon is 1s2, 2s2, 2p2. Now 1p orbital is empty. Now, if hybridization did not exist, according to valence bond theory, only the valence orbitals participate in bond formation. Now, if that was to take place, that means that the 4 hydrogen atom combine with s and p orbital of carbon to form 4 bonds. It means that all the 4 bonds would not be of same nature, because one would be the combination of s and s and the other would be the combination of s and p. But when experimentally we find out that all the 4 bonds are of same energy and of same length and same nature. So this concept can be explained only with the help of hybridization. So in hybridization, what happens is, firstly, the 2s orbital electron of carbon is excited to the vacant site of the p orbital, and four orbitals having 4 electrons of equal spin, same spin, they combine together or intermix, or hybridization takes place, and resulting into the formation of 4sp3 hybrid orbitals. Now all these hybrid orbitals, they align at the 109.5 degree angle, which is experimentally verified. So this explains the need for hybridization. It means before any bond is formed in any molecule, the orbitals of the valence orbital of the central metal atom or central atom, be it metal or non-metal, the valence orbitals of the central metal, they combine and they hybridize to give rise to the degenerate orbitals, valence orbitals, and leading to the particular symmetry or geometry of any molecule. So this was all about the origin of hybridization. Students, I hope you understood the topic. Stay blessed. Happy learning, students. Bye-bye. See you in my next video.